Hello guys, my name is Hiqmah
And my name is Puteri Sarah.
and today we are going to explain the theory behind Stokes theorem. First of all, Stokes theorem is a higher dimensional version of a closed curve in 3 dimensions, where the curve itself is the boundary of surface here, which we assume the surface to be surface S. Just as the green theorem, we assume that the direction of the curve is in counterclockwise, and it also with the respect of normal vector of the curve. Now, imagine that there's a little error everywhere here acting on the space, which we call it as vector field. And we want to calculate the amount of vector field that acting in the direction of the curve. And that's where the Stokes theorem are going to be used. First of all, to find the direction of the vector field in the direction of curve, we need to take the line of integral of f along C. And actually, this thing is equal to the surface integral of the curve f dot n ds.
Okay, then what is curl F? Curl F is equal to del cross F. So we can put this inside the formula. So the curl F will be del cross F dot, the normal vector will be the same and ds, which is the small area, can be written as dA. So there will be 2 cases, which is the first one if it is a circle. So if it's a circle, the formula will be del cross F dot, the n will become r theta, which is the angle, cross r, which is the radius. Then the dA will become d theta dr. And if it is other than circle, it will be del cross F dot rx cross ry dx dy. Okay, so in analogy, now I want everyone to imagine that there's a thin fabric shaped like a disc. So the wind will be the vector field. So calculating how much the wind circulating around the edges of the fabric, that's what we call as line integral. And calculating how much the wind swirl through the entire fabric, that's what we call the surface integral of the curl. Basically, in Stokes theorem, it says that both are equal. That's all from us. Bye.
Hi, good evening everyone. My name is Fatin Sarah and this is my partner.
Hi, my name is Sarah.
And today we show you example use Stokes theorem to evaluate the grid C f dot dr. And from the equation, we can take out x equal to x plus y square, y equal to y plus z square, and z equal to z plus x square. And first thing we have to know that when we have C, we have to take out the width ties. From the diagram, we know that z is 0, 0, 1 and y is 0, 1, 0 and x is 1, 0, 0. And the first thing we have to do is we have to find the curve. And from here, we see that the formula of the curve, double integrate over s curve f dot n ds, and just use a basic formula of curve, then multiply by f, and we find that put I, j, k, and d over dx, d over dy, and d over dz, and put the value of x, y, z here. And the final answer is negative yz, negative yx, and negative 2y. And take out negative 2 outside, and you will get negative 2 x, y, z.
From here, we will get the formula ax plus by plus c d equal to d. We assume d is 1 because the triangle is up positive z. So from here we take out z equal to 1 minus x minus y. So and dx equal to rx cross ry dA. We find rxy equal to x y 1 minus x minus y. From here we find rx equal to 1 0 minus y. We find ry equal to 0 1 minus 1. So we will find rx cross ry. From here we insert the value for rx and ry. This is rx and this is ry. Then we will get 1 1 1. Then we will combine the value of these two. We get integral s equal f dot n dx equal to double integral s minus 2 z x y dot 1 1 1 dA. We get double integral s minus 2 z plus x plus y dA. From here we insert z equal to 1 minus x minus y. We get double integral s minus 2 dA.
Hi, Assalamualaikum and good evening everyone. I'm Athirah.
I'm Anis.
So today we will explain to you how to use Stokes theorem. So for today, we are given circle example. So this is our value of f. So first thing that you need to do is clarify your value of x, y and z as how I did here. Alright? And then next, we need to find the curl of vector field. So this is how we find it. I think you all familiar with this kind of calculation, right? Next, after we write down this, just do some calculation. And don't forget your I, J, K. And then when we simplify, we will get the answer of f, which is negative 6x, negative 6y, and 12z.
So, we continue with finding ds. ds is the surface area. Before finding ds, we need to know the range used to calculate the surface area. So, here we are talking about the flat circle surface. Like this is z-axis. The z is equal to 7 because the circle is on the 7. 3 we got from the equation here. X squared plus y squared equal to 9. It can also be square root 9. So that's why we got 3 here. 0 and 3, center of the circle is 0 and then the distance is 3. Now the theta. 0 here and 2 pi here, we make 2 pi. In order to complete the circle, this range is actually generating this flat surface on the coordinate. Next, R. So here, we got R sin theta, R cos theta, and 7 from the value of x, y, z. The normal vector, we have two equations. We can use Rx multiplied by Rv or R theta multiplied by R. In this case, we are doing for the shape of circle. So we use R theta multiplied by R. So this R theta resulting from when we differentiate this value. So we get this value. And then for the RR, we get from the result of differentiating R value from this equation. So from here, we convert it into the form of vector to solve it. So that we got the final answer 0, 0, R.
Okay, then this is the last step by using Stokes theorem. So first we need to write down our formula, and then this is the answer that we got from the curl f, and this is the answer that we've got from normal vector. And then we multiply negative 6 6x with 0, negative 6y with 0, and 12z with r, and then we've got the answer of 0, 0, and 84r. So the 84 comes from 12 multiplied with the value of z, which is z is equal to 7. Then we've got the answer of this. And then we just substitute into the formula. And then for the first integral, we've got 378. And the last answer is, the final answer, we've got 756 pi.
So that's all from us for example number 2.
Hi everyone, my name is Naomi.
And my name is Nailana.
We are going to present about Stokes theorem, a real world example. We have the question which says a fan rotates in a room generating an air velocity field f of x, y, and z equals to minus y, x, and 0. Let S be a flat circular area of radius r on the ceiling at height z equals to h directly above the fan. The boundary of this surface is the circle C. Use Stokes theorem to calculate path C. Well, first we have the first step. We just write down the Stokes theorem. We know that line integral of f along C is equal to the surface of the curve times f and ds. Okay, here we have the Stokes theorem. The second step is to compute the curve of f. We know that del times f is equals to all the components I, j, and k, and then we write down the partial derivative of x, partial derivative of y, and partial derivative of z, and then we just write down the x, y, and z components. Okay, here we have minus y, x, and 0. First we just determine the components. Here we know how to do it. We just need to cover this part and cover this part, and here we have partial derivative of y times f of z, which is 0, and minus partial derivative of z times f of y, which is x. Here we have, and now we have 0. We just need to do this for each component. First for I, then for j, and finally for k. Here we have the curve determined, which gives us 0, 0, and 2. Now we get the curve values 0, 0, and 2. What does it mean? It means that the rotation is purely around z-axis, which makes sense because the air is swirling in the plane x, y like a fan.
And now I will continue with the step 3, the normal vector. To find the normal vector, we need partial derivative of x, y, and z to know the normal vector. And we know the normal vector. Now we go to the step 4, surface integral del cross f dot n ds. It's equal to surface integral to ds. And we know that surface integral ds is equal to 2 times area of the circle. Who give us a solution who have 2p r squared. Now we finish to the step 5, who have the circulation along C. Line integral of f along C, who gives us to the same formula, is surface integral del cross f dot n ds. It's equals both, it's the same thing. So we already have the surface integral, so now we have the results here. That is 2p r squared. And to conclude, we know that the circulations 2p r squared measuring how strong the air circulated around the circle.
Large circles capture more rotation.
So this is the end of our presentation, and
bye!
Bungkus, bungkus, bungkus aku dong. Bungkus, 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 jangan